everyone. This is a short video for section 5.3, differentiation of logarithmic functions. So if you have a basic logarithm, when I say that I mean just the log of x, then the derivative is simply 1 over x. So that's the first rule we need to know. If you look at it more closely, think of it like this. The x here that's on the bottom is basically coming from what we're taking the log of here. Okay, so whatever we're taking the log of goes on bottom. And then your numerator, you have 1 here. Well, 1 is the derivative of x. So basically the top's the derivative of the bottom. Okay, so we can say this in a more generic sense. If we have the log of something with x in it, so we're calling it log of f of x here, then the derivative is still a fraction. The bottom of the fraction, again, is whatever's in the log. So in this case, f of x. And then the top's the derivative of the bottom, so f prime of x. So if we have these two rules down, we should be able to do everything in this section. So let's go straight over to it. You should have a question like this as your first homework question. Find the derivative of 5 plus the log of x squared. Well, the derivative of 5 is 0, so that's gone. We need to look at the log of x squared, though. So we're going to use the second form of derivative of a log here. So again, the derivative of a log is a fraction. The bottom of the fraction is whatever you're taking the log of. And then the top is literally the derivative, f prime, derivative of the bottom. Okay, so let's do that here. So we have the log of x squared. The derivative of a log is a fraction. Oops. Okay, the bottom of the fraction is whatever you're taking the log of. We're taking the log of x squared here. And the top is the derivative of the bottom. So the derivative of x squared is 2x. Okay, now I didn't simplify here. You could go and cancel out an x and just get 2 over x. That would be fine. I just didn't do it here. Okay, so great. All right, let's see what's next here. Okay, so word problem, but it's still basically just asking for a derivative here. Carpenters determined the profit from the sale of x shells is given by this function. So it's a profit function, 31x plus the log of 7x squared plus $22. Find a marginal profit function. Well, marginal just means derivative. So it's asking us again to take the derivative of this function. So the derivative of 31x is 31, just with the power rule. And then your second term is a logarithm again. Okay, so we've got to use that same derivative of a log rule. So again, the derivative of a log is a fraction. The bottom of the fraction is whatever you're taking the log of. So in this case, 7x squared plus 22. And the top is the derivative of the bottom. So the derivative of 7x squared would be 14x. Derivative of 22 would be 0. So it's gone. Correct. Okay. All right. Next problem. Notice in this one, they don't have a plus or a minus sign in between 2x cubed and the log of 5 minus 8x. What this means is this is all one term. So you need to think back to the last test where we did the product rule. Let 2x cubed be first, and then let the log of 5 minus 8x be second. So if you remember, the product rule is first times the derivative of the second plus the second times the derivative of the first. So let's just fill into that. So first is 2x cubed times the derivative of the second. So now we need to do the derivative of the log of 5 minus 8x. Okay, so again, the derivative of a log is a fraction. The bottom of the fraction is what you're taking the log of, which is 5 minus 8x. And then the top is the derivative of the bottom. Derivative of 5 is 0. Derivative of negative 8x will be negative 8. So that's d second. Okay, plus second, which is the log. Now you can't type ln on here. You need to actually go to the keypad and hit ln. Okay. So that's the log of 5 minus 8x times the derivative of the first. So the derivative of 2x cubed is 6x squared. Okay. So there we go. So we got first, derivative second using the logarithmic derivative rule, plus second times derivative of the first. Okay, there we go. Okay, this is the exact same thing. I'll let you do it. Let's skip to the next one here. Okay, this one you have the log of 20 minus 23x squared raised to 5. You need to be careful with where the exponents are in this section. So this 5 right here is on what I would call the interior parentheses. In other words, 20 minus 23x squared is raised to 5. The log itself is not raised to 5. There's a rule in algebra that says this. Let me type it up for you here. It says this: if we have the log of x to an exponent, let's call the exponent n. Okay, that's equivalent to having n log of x. Okay, let me zoom in a little bit here so you can see a little bit better. Okay, so there's our rule. Okay, basically what it's saying is the exponent on the argument can move out in front as a coefficient. Okay, why do I say that here? Well, if you look at this problem, we could do that. We could take this 5 and stick it out in front of the log. So really I have well, it's not agreeing with me here. Hold on. Really we have y equal 5 log of 20 minus 23x squared. Okay. And if we have that, well, put that back over there, then we don't have to worry about that exponent on the parentheses anymore. Okay, so notice the difference here. This is how it's shown on Hawks. The 5, this exponent in this case, is on the interior parentheses. So anytime that occurs, I can just move that 5 out in front of the log. So that's what I did right here. I took the 5 and I put it in front of the log. 5 is just a coefficient now. So if I want to take the derivative, I can just move that exponent, that coefficient down. All right, so 5 can come down, and then I just need to worry about taking the derivative of the log. Okay, so we're going to get a fraction. The bottom of the fraction, again, is whatever you're taking the log of. We're taking the log of 20 minus 23x squared. And, oops, how did that happen? Why is that there? Well, sorry, Word is not working for me. There we go. and then the top is the derivative of the bottom. So derivative of 20 is 0. The derivative of negative 23x squared will be negative 46x. Okay. And you're not really accomplishing anything by simplifying on these, so let's just type it in just like that. Okay. So 5 goes out front, and then you have the derivative of the log, which is 20 minus 23x squared on the bottom, and then on the top is the derivative of the bottom, so we said it was negative 46x. Okay. All right, so again, that is when that exponent, 5 in this case, is on the interior parenthesis. There's one other situation, something like this. So if you look at it, it's got the log of x all cubed. Notice the 3 here is on the exterior parentheses. The entire log is raised to 3. Well, that doesn't fit. Oops. That doesn't fit this rule we have here. This is only when an exponent's on an interior parentheses. Okay? So all we can do here is treat it as it is. Okay, so if you look at this, this has x buried in a parenthesis raised to an exponent. You did that on the last test. You called it the chain rule, or more specifically for us, it was the general power rule. Okay, so there wasn't a mnemonic or anything for that, but the rule was you moved your exponent out front, then you rewrote what was in parentheses, so log of x is what's in parentheses here. Okay. Then you subtracted 1 from the exponent, and then you multiplied times the derivative of what was in the parentheses. So we need to do the derivative of the log of x. So that's actually our first rule. Derivative of log of x was 1 over x. Okay. And again, there's no need to simplify on these. Okay. So there it is. General power rule, or chain rule if you prefer to call it that. Exponent out front, rewrite what's in parentheses, subtract 1 from the exponent, times the derivative of what was in the parentheses. Okay. All right, there's 2 more questions on here. I'll let you work on those. Obviously this one here, it's going to be a quotient rule problem, so you're going to have to do low d high minus high d low all over low squared. Actually, I'll go ahead and do it. Why not? Okay. So we've got x's divided by x's, so we've got low, so the log of x cubed is low. Times the derivative of high, so the derivative of 22x squared will be 44x, minus high, which is 22x squared, times the derivative of low. Okay, so we have the derivative of the log of x cubed. So again, the derivative of the log is a fraction. The bottom of the fraction is what you're taking the log of, which is x cubed. The top is the derivative of the bottom. So the derivative of x cubed is 3x squared. Okay. So this is low times derivative high minus high times derivative low, all over low squared, which is just where you're going to take whatever's on bottom. Oops, hit the wrong button. You're going to take whatever's on bottom, put it in parentheses, and square it. So we'll have the log of x cubed squared. Now be careful where you put your squared sign. It's the entire bottom squared. So it needs to be on the outer parentheses. If you put it on the interior parentheses, if you put it right here instead of here, it wouldn't be correct. It's got to be the entire denominator in parentheses, all squared. Okay. And there we go. Okay. And this will be, in essence, the same thing. Low d high minus high d low over low squared. Okay, so I'll let you do that. All right. that should do it for this test.